Find f prime of x and f bis of x, second derivative, given that f of x equals x to the fifth times e to the x. Again, we have a function that's written as a product of two functions, so we can use the product rule. The product rule says that we take the derivative of the first multiplied by the second. So the derivative of x to the fifth is 5x to the fourth, times the second, which is e to the x, plus the derivative of the second times the first function. The derivative of e to the x is e to the x, times the first function, which is x to the fifth. We can factor out an e to the x, and so we've got e to the x times x to the fifth plus 5x to the fourth. I'm just putting those in standard form out of habit, and I forgot to write in the very beginning that this is the derivative, so I'm just going back and putting in that prime there. So we have our first derivative. Now, if we want to calculate the second derivative, if we want to differentiate what we already have, we can notice that the result is a product of two functions. So again, we can use the product rule. We have the derivative of the first function, the derivative of e to the x is e to the x, times the second function, x to the fifth plus 5x to the fourth, plus the derivative of the second function times the first. The derivative of the second function is going to be the derivative of x to the fifth plus 5x to the fourth. We can do that no problem. The derivative of x to the fifth is 5x to the fourth. And the derivative of 5x to the fourth, well, the derivative of x to the fourth is 4x cubed, but if we multiply that by 5, that gives us 20x cubed. So remember, we had the derivative of the first times the second, plus the derivative of the second, and we still need times the first. So we still need an e to the x there. We can factor out our e to the x, and when we combine all of the leftovers, we've got our x to the fifth. Notice when we take 5x to the fourth plus 5x to the fourth, that's going to be 10x to the fourth, and then we still have that plus 20x cubed. And this is our final answer for the second derivative. If you really wanted to, you could notice that all of those terms have an x cubed in them, and so you could pull out the x cubed inside those parentheses, leaving us with x squared plus 10x plus 20. In fact, maybe that would give us something that is nicely factorable even further, though there aren't two integers that multiply to 20 and add up to 10, so it's not going to factor nicely. But I just wanted to do this because we can technically break it down further, and there are situations where this could be factorable even more, and we might want to have everything factored out, because if the next step is figuring out when the derivative is equal to 0, when this second derivative is equal to 0, having it in factored form is what's going to help us figure out that solution. So could be helpful to factor things further if it looks like it factors nicely.